All right. Oops. Oh wait. Maybe that should not. Just remember now. Eventually, this gonna turn on. Yeah. Yeah. Let me see a question.
Because I'm trying to figure. This is based on what
Yo,
we did here.
nah, we need to get to that. Yeah,
So you're
I'm
gonna
doing
do
that
it
right now.
today?
Yeah.
Okay.
Yeah.
Because I was like, wait a
So you
minute.
see right here where it says grades? I click that. All right.
Okay.
So at the end of the semester, scroll down. All I look at is that percentage right
This
there.
or this.
That one.
There's
That's your
one
homework grade.
that for some reason it doesn't come out. What am I doing?
Oh yeah, let me know about those when if it don't come out.
Uh, 20 of
No, no,
them.
go to grades. Go to grades. So,
Great.
so
So
here's what you should do,
picking.
right? You see like how this one right here, you're missing one question from that for it to be 100.
Okay.
So you just click here, and then you can just do that question. Click on
What is
problem
this?
3.
See, this is the one. It doesn't say what's
I think the ratio is a question mark.
question.
Yeah. Let me see. So the temperature.
This is not crazy. I
Pause this real quick. Let me show y'all what I was just showing. Bear with me 1 second. Second. I want to stop sharing. Let me share again. All right, so let me show y'all something, right? When y'all are on web work, right? And you're on the left-hand side, there's gonna be a button here, whatever, called grades. Click on grades, right? When you click on grades, at the end of the semester, if you scroll all the way down to the bottom, you see right here where it says homework totals, that percentage, that's your homework grade. That's all I look at, right? I'm not looking at how many times you try it. I'm not giving you a penalty for trying a question. All I want is that bottom percentage right there to be 100. That's it, right? Mhm. All of that, everything, right? So, and a good way to do your homework too, look at each homework that's posted, right? You see how you have the percentage right here? If it's not 100% in green, that means that there's a question missing there. So all you do is you just click on it, and then it takes you to the homework set, and then you just do whatever is missing, you know? That's fine. Yeah, that's fine. Remember, homework is like majority of your grade, so you wanna really like do well on it. Like I'm telling you, like I've seen people pass off of just homework, like keeping it 100 with y'all, and I've seen people fail because of homework. You know, that's another thing too. You know? Yeah, and I mean, to be honest with you, when you're doing the homework, you're just practicing the test questions. That's all it is. You know. Well, at least for the final, like my questions are the actual homework questions. Uh, yeah. Yeah. Oh, my test? Nah, my test is easy. It's just the homework. I got you. I got you. The secret is you just use the formula sheet. That's all you need. Like anytime you don't understand something, you just look it up. Hmm. Yeah. You're gonna get both of them. Two of them, not the third one. The one that is web work, there's no need for that. Yeah. Yeah. So, any questions? Anybody wants to go over? All right. So, all right. Give me a question.
Same question.
All right. Let me see.
You told me to keep clicking and
Yo, for real, yo, I swear this is a multiple choice. Oh my God.
it's the same one.
You serious? Just click and just submit. Yo, you almost there. Hold on, let me do it real quick. Are you almost? Oh shoot, you almost there. I watch. That's how you do it right here, right? You got B right here. Let's say I go to A. I don't know why that keep happening. And I hit this. Right? See how that went to zero? That means that B was right. Right? So B is right. See? Now you go to the next one, right? We know A is not right. How about B? We know B is not right. How about C? All right, C is right. And then we do keep going with this one. Let me see. How about D? We know B, we know it ain't B. All right, it ain't D. All right, we know it's not B, we know it's not D. How about A? Nope. How about C? That's it. Easy, right? I didn't even read the question. I don't even know what topic this is. But that's how you do it. You can go back now and study it because you got all the right answers. You know? And then you see, like here, 67%, something's missing. 93%, something missing. Right? How you did all of this, I have no idea. I ain't even do that. That's what I'm doing today. Well, good job. Right? That's good. You get to use that on the test day too.
But look, this is good, right? Because
Yeah. Make it 100. All right. All right. What's your question? Just read it to me though. Yeah. Unless it's like a multiple choice thing. I don't know. One second. Let's see. Fix it. Let me see. Okay. All right. Somebody emailed me this before. So we have S is equal to 1/5. And we got T is equal to 1 and 6/7. Right. And then they want to know what is T squared over S. All right. It's not so bad, right? So what you want to do, you want to change the T right here, right? Change that into a improper fraction, right? So 1 times 7 plus 6. Okay, that'll be a numerator, right? So that's 7 plus 6, what's that? 12, 13, right? So this would be 13/7. Now that you have that, just plug it in down here to what they're looking for, right? So this is going to be 13/7 squared over the S, which is just 1/5, I believe, right? Yeah, 1/5. Just like that, right? Square the top and the bottom. This becomes what, like, I think it's 169. You should check me on that. And then this is 49 over 1/5. And then after that, keep change flip, right? Just keep change flip. So this is going to be 169 over 49 times, we'll flip this, right? 5/1, right? So what's your final answer? It's 169 times 5 I don't know what that is. That's why I'm writing it like that. Over 49. But multiply this top part together, then that'll be it.
Okay.
Yeah.
This is not so-
Yeah. Whatever that is. Yeah. Hey, what you got? Ooh, this should definitely be on your test.
Really?
Yeah. All right, so this one, right? We have -1 times 5 plus 6 times 7, right? So what we want to do, we want to do PEMDAS, right? So please excuse my dear Aunt Sally, right? First thing we want to do is the parentheses. I don't have any parentheses, so I'm done with that, right? Next, we want to do the exponents, right? So that's like x to the second power, right? No exponents here. Done with that. Then you want to do multiplication and then division, right? Like from left to right, right? So that's like times and hold on. It's like times and division like that, right? Over here we have that. So let's do these individually, right? -1 times 5 is what's that?
Ah, you asked me. Oh,
Yeah.
what was the question?
Yeah, so -1 times 5, I'm multiplying. What do I get?
Negative.
Negative
Wow.
5, -5, right? Plus, right? What's 6 times 7?
5, 6, I think it's 40 something.
42, right? Okay. Now, after you get that, you just have to add these together. So what's -5 plus 42?
40.
30. You're right. 30 something.
Yeah.
30 what?
Hold on. Wait,
Mhm.
wait, 38. No, no, 37.
37. Very good. But that's it.
Oh,
Yeah. So the next one
is
um,
0.7.
times, oh, 0 times 7 or 0.7? See. So I have 0 times 7 minus 5 times 10. All right. So now anything times 0 is, right? So this is 0. And then bring down the minus sign. And then what's 5 times 10?
50.
Very good. All right. So my answer is just -50. That's it. Mhm. You're welcome. Anytime. Mhm.
Oh,
Okay. All right. Oh, her?
mm,
No, that's Susan, no?
um,
Got you. Got you. Yes. Um,
well, few questions actually.
oh yeah, we just
The
did the
first
other
one
one.
is, how do I find the standard deviation?
We didn't do that yet. That's actually the lesson for today.
Oh,
Yeah.
okay, but am I on the right path?
Yeah.
Okay.
There's more to it. I'm gonna show you. Yeah, don't worry.
Then,
So the trick here, right? You change this so improper fraction, then you just plug it in. You know? We could do that one right now if you want. All right. So I got P is equal to 1/7. And then I got Q is equal to 4 and 6/7. And then they want to know what is P squared Q. All right. So I'm saying for Q, change that to an improper fraction. So 4 times 7 plus 6, that's like 28, 34, I think. Am I right about that?
yeah,
Yeah, so like 34/7, right? After you got the two fractions, just throw them in down here, right? So the first one was P squared. So then that's going to be what? 1/7 squared times, or parentheses, 34/7, just like that. right? You're gonna square this first term, right? Individually. So 1 squared 1, 7 squared 49. So this becomes 1 over 49 times 34 over 7, right? And remember how we multiply fractions, just go straight across, right? So this would be 1 times 34 is just 34 over, I'm not even gonna lie to you, I don't know what this is, 49 times 7. Do the multiplication on that, and then you're good to go. That's it.
And then when I multiply the multiple, that'll be my answer.
Yeah, yeah, whatever that is. Let me see what it is. Hold on. 49 times 7, what is that? 343. So this is 34 over 343. That's it. Yeah.
Let me write that down, so when I do the whole equation myself, this should be the answer before.
Yeah.
And then this one.
So,
See, initially I just broke this in half and divided 45
So-
divided by 2.
a little different. So this is 1/2 times square root 45, right? But what you want to do is you want to reduce the square root, right? So this becomes what? Square roots 5 times square root.
3,
Mm-mm. That's 15.
2.
That's 10. I need 45.
Mm.
Like 5 times what is 45?
Oh, 5 times 9.
9, that's it. Right? And then that's times 1/2. Right? And then the square root of 9 is what again?
5.
No, what's the square root of 9?
Oh, 3.
3, right? So this is 3 multiplying straight across. So pretending this is over 1, right? This is 3 square root 5 over 2. That's your answer. Right? Now they want an answer that's like A over B square root C, right? So in your case, this would be like 3 over 2 square root 5. So you just plug it in for A, B, C. That's it. Yeah. Mhm. Gotcha. Mhm.
Right.
See which one we got.
Like, there's the same like the numerator has to be less than the
So change this into a proper fraction. So that's going to be 1 times 7 plus 6. That's 13 over 7, right? Yeah. But it's going to be 13 over 7 squared divided by s, which is 1 over 5. So 169 over 7 over 49, excuse me, times 5 over 1. That. And you just multiply 169 times 5. Let me see what that is. Because I don't even know.
That's 825 over. Yeah, that's
845
845.
over 49. And then that's it.
Yeah, that's what I did. It's like still saying it's wrong. Right, Jay.
Um, oh, see right here, they want a proper fraction or a mixed number. So let's change this to a mixed number. All right. So what you want to do, you want to know how many times 49 going to 845. You know? And then when you get the whole number, whatever it's going to be, the whole number, let's just say 1 over whatever the remainder is at the bottom, right? Let's say that was 2 over the divisor, which is a 49. And that's what you'd have to answer in that question. Yeah. Mhm. Hey,
Hey, who lost me?
I lost you? That's rare. Oh wow. Wait, I didn't teach that yet. How you got hundreds already on everything?
Just 1 or 2.
All
After
right.
that, I don't know. You just want.
I got you. I'm gonna show y'all that today. Proud of you. Or I want to see something. I'm just curious how we looking over here. Yeah. So like all these, like finish these up. He's like one question missing here, one question here. That's
Really
true.
looking.
I got you.
But like this one was the one that was looking.
This one.
Sorry, stop following.
So you know what's hard about this? So they want the actual numbers that fall in between here. So like 27, comma, 27, comma, 20, like that. That's what they want.
I was using CodePython to teach myself how to do it.
Yeah.
And I was just like, I still don't get it.
It's related to like the whole class thing that we did with the classes and how many numbers fall in between each class. But this particular question is asking you specifically what numbers are in the class. So that's what you write, the actual number, and then comma, the next number, and comma, the next number.
So that show numbers on that list, right?
Exactly, that is stuff right above.
We'll see, because I didn't make those up. I was just like, what the hell?
Gotcha, gotcha. So we good? Yeah. All right, let's get into today's lesson. This is gonna be fun. Can we what? By the way, I know I owe you guys a announcement. I'm gonna just do like a super announcement today. All right. So we're doing measures of variation, right? So an average is an attempt to summarize a set of data using just one number. As some of our examples have shown, an average taken by itself may not always be very meaningful. We need a statistical cross-reference that measures the spread of the data. So the range is one such measure of variation, right? So the range is the difference between the largest and the smallest values of a data set. So long story short, you take the biggest number, you subtract it from the smallest number, and that answer you get will be the range of your data. All right. All right. So for example, a large bakery regularly orders cartons of Maine blueberries. The average weight of the carton is supposed to be 22 ounces. Random samples of cartons from two suppliers were weighed. The weight in ounces of the cartons were, as you can see, supplier one, 17, 22, 22, 22, 27. Supplier two, 17, 19, 20, 27, 27. We want to compute the range of the carton weights for each supplier. So the range is the largest value minus the smallest value. So for supplier one, our largest value is 27, and our smallest was 17. Subtract that, we get 10, right? For supplier two, the largest value is 27, the smallest value was 17. For that, we also got 10, right? That's our spread. Next, we want to compute the mean weight of cartons from each supplier. In both cases, the mean is 22. So it's like we really can't analyze this because they're so similar, right? So we want to look at the two examples again. The samples have the same range and mean. How do they differ? The bakery uses 1 carton of blueberries in such blueberry muffin recipes. It is important that the cartons be of consistent weight so that the muffins turn out right. Supplier, one provides many cartons that have weights closer to the mean. Or put another way, the weights of carrots from supplier one are more clustered around the mean. So the bakery might find supplier one more satisfactory. All right. And then as we see in the next example, though the range tells us the difference between the largest and smallest value in distribution, it does not tell us how much other values vary from one another from one another or from the mean. Hmm? All right, next we want to talk about variance and standard deviation. All right. So variance and standard deviation. So we need a measure of the distribution or spread of the data around an expected value, either X bar or mu. Variance and standard deviation provide such measures. Formulas and rationale for these measures are described in the next procedure display. Then examples and guided exercises show how to compute and interpret these meanings. And then, as we will see later, the formulas for variance and standard deviation differ slightly depending on whether you are using a sample or the entire population. All right. Okay, let's talk about the procedure. So how to compute the sample variance and the sample standard deviation, right? So this is what some of you guys are asking for homework. Let's say we have a quantity X. The variable X represents the data value or the outcome. The mean, X bar, is the sum of all of the X's divided by N, the number of numbers. So this is the average of the data values or what you expect to happen the next time you conduct a statistical experiment. Note that N is your sample size, right? X minus X bar, this is the difference between what happened and what you expected to happen. This represents a deviation away from you accept and or excuse, yeah, expect and is a measure of risk. All right. Now the sum, essentially this one, the sum of X minus X bar squared, the expression sum of X minus X bar squared is called the sum of squares. The X minus X bar quantity is squared to make it non-negative. The sum is over all the data. If you don't square the X minus X bar, then the sum of X minus X bar is equal to 0 because the negative values cancel the positive values. This occurs even if some X minus X bar values are large, indicating a large deviation of risk or risk. Okay. right? Then we have our sum of squares. That's going to be the sum of x minus x bar squared, or the sum of x squared minus the sum of x squared divided by n. So this is an algebraic simplification of the sum of squares that is easier to compute. The defining formula for the sum of squares is the upper one. The computation formula for the sum of squares is the lower one, right? Both formulas give the same credit. Okay. Questions on this? Hmm? Yeah, that's it.
So whenever you see those
Mhm.
lines, that's what it means.
Right. Mhm. Don't worry, you're gonna have a formula sheet to help you. Hmm.
So that would be here.
Yeah, that means atom formulas that is above it. That's all it means.
I don't remember, that's the sum.
That's it. Yeah, sum is yeah, yeah, but different. You're trying to figure out how spread out your data is. You know? Let's continue. Mhm. I got you. So we good next Thursday, right? Next Thursday.
So for this next Thursday, that means you're gonna add this one here.
This is already on it. Yeah. The stuff we're doing tomorrow is not on it. Yeah. That's why the homework's not open for tomorrow. Yeah. So
Oh, tomorrow, next week.
yeah, that's following week. Yeah.
Look at the proven Monday, Thursday, we go for the chill everything.
Yeah, next week. Yeah. Yeah, next week. All right, so sample variance, right? S squared is equal to the sum of x minus x bar squared divided by n minus 1, right? That's our defining formula, right? Then we have another one right below, which will give you the same answer. Let me be clear about that. No matter which formula you use, you'll get the same answer, right? So the bottom one is the sum of x squared minus the sum of x squared divided by n minus 1, right? So the sample variance is the variance can be taught of as a kind of average of the x minus x bar squared values. However, for technical reasons, we divide the sum by the quantity n minus 1 rather than n. This gives us the best mathematical estimate for the sample variance. The defining formula for the variance is the upper one, and the computation formula for the variance is the lower one. Both formulas give you the same result. All right. Questions about these formulas? Yeah, yeah. I got you. We're gonna do the one. Yeah, yeah. So we're gonna go over both of these. Yeah. Mhm. Depending on which formula you're using. Yeah. But it depends on this too. So right now we're talking about variance, but you can see there's two formulas right here for variance. All right. But we're gonna talk about it. This is on your formula sheet, so you don't gotta memorize it. All right. Just wanted to throw that out there. Yeah. Everything is on there. The answers to the whole test is on there. Yeah.
In box.
Mm-mm.
This X minus, X bar squared. We got X, and it is X minus X bar.
The whole formula is the variance. The whole thing with the n minus 1. Yeah. The top part that you're describing, that's the sum of squares. That's what that is. Yeah. All right, let's talk sample standard deviation. So here goes our sample standard deviation formulas right here, right? So we have the square root of the sum of x minus x bar squared divided by n minus 1, or we could do the square root of the sum of x squared minus the sum of x squared divided by n and then divided by n minus 1. So this is the sample standard deviation formula, which is S, denoted by S. So why do we take the square root? Well, if the original X units were, say, days or dollars, right, then the square, S squared units, would be days squared or dollars squared, right? Wow, what's that? We take the square root to return to the original units of the data measurements. The standard deviation can be thought of as a measure of the variability or risk, right? So larger values of S imply greater variation in the data. So the defining formula for the standard deviation is the upper one, and the computation formula for the standard deviation is the lower one. Both formulas give you the same result. And be clear about that. And this is on your formula sheet. All right. Questions on this? Same answer. Yeah. So, like on your test, I'm asking you for the standard deviation, but I'm not telling you what to do. You got options. Whatever y'all want to do, just give me the right answer. Mhm. Yeah. Yeah. I recommend showing your work. Yeah. After we go through some more theory. So in statistics, the sample standard deviation and sample variance are used to describe the spread of data about the mean, right? The next example shows how to find the quantities by using the defining formulas, right? Which shows us how to use the computation formula. So as you will discover for hand calculations, the computation formula for S squared and S are much easier to use. However, the defining formulas for S squared and S emphasize the fact that the variance and standard deviation are based on the differences between each data value and the mean, right? So you want to figure out on average, what is the distance that each number has from the mean? So defining formulas, sample statistics, we have sample variance is a sum of x minus x bar squared divided by n minus 1. Sample standard deviation is the square root of x minus x bar squared divided by n minus 1, where x is a member of the data set, x bar is the mean, and n is the number of data values. The sum is taken over all data values. Computation formula. So we have sample variance S squared is equal to the sum of x squared minus the sum of x squared divided by n, all divided by n minus 1. Sample standard deviation is the square root of that answer. So the square root of the sum of x squared minus the sum of x squared divided by n minus 1, where x is a member of the data set, x bar is the mean, and n is the number of data values. So the sum is taken over all these data values. Questions on this? Okay. Like right here? Okay. That's the bottom one. All right, try this out for me. Mhm. I know most of you could do it because y'all got hundreds on y'all homework before I even taught y'all how to do it.
Wait.
Sure. Sure. It's on your formula sheet too. Yeah. Which you're allowed to use, by the way. Before it? Right here. It doesn't matter. Both will give you the same answer, so it doesn't matter. You're welcome.
This is the sample, right?
Yeah. So that's the x minus x bar squared. It is the same thing.
So they just want us to find the same thing? So why say that? Just say, find this.
But just find a standard deviation. On my test, I just tell you find a standard deviation. I'm not telling you how to do it. Whatever is easiest for you, you do. So we gotta do the chart. I feel like y'all all know how to do it though. See? Okay. I'm impressed. Good. Keep going.
There's more.
Yeah, standard deviation. Yeah. The standard deviation, this formula. This thing. Got you. Give y'all a few minutes. Yeah, we multiple. Y'all could talk to each other, you know. I'm okay with that. Y'all working together, everything. See, I don't have mad time to study. I should add questions to the test. Honestly, this is probably the hardest question on your test. Mhm. Because the rest of it is like +2 +3, 15 -2. +1/2 in decimals. Good job on the minute. Good job.
But it's right.
Yeah. So, right? Um,
So what, what's so wrong?
what you want to do is you want to square all of those numbers, then add it.
Oh, because that's what next I was gonna ask you, am I supposed to square it automatically?
Yeah, and then add it.
So, so square these numbers or square the six?
No, square those numbers. Then add it. And then that's the numerator. So
Is this gonna be on the test? Cause I don't know how to do it.
it is. But it's really easy though. Just follow the formula. You're gonna come. Yeah, I'm thinking your hair. That's cool.
Thank you.
So perfect. So what you want to do, find the mean, and you're gonna subtract the mean from every individual one.
This is the mean.
Yeah, so like 2 minus 36, 3 minus 36, etc.
Until
And then those answers you get, then you're gonna square those answers and add those up.
each answer, so like this 34 square and then.
Exactly.
Oh my gosh, that's a lot. Okay.
You sure that's the mean? No, that's kind of big.
Wait.
And then divide by it. Yeah. Because the idea is, right, the mean is a measure of central tendency, right? So it should be like between them numbers. Like 36 sound kind of large. I don't know. Got you. Oh yeah, you're right.
Yeah, I did, yeah.
Because I'm like looking at it now, like, yeah. Huh? It is?
It's a lot.
It's copy
Yeah, it's a
formula.
whole, like, I had to just try to see, like, I'm just like, breaking it down. So what is it?
Just find the standard deviation. So what it is, right? Like what I'm actually looking for, y'all gonna find the mean, right? And if you were to subtract each one of these numbers from the mean, that's giving you a distance, right? That each number is from the mean, right? What I want is I want an average distance from the mean. So you're gonna add up all those distances, right? Then you're gonna divide it by how many distances there are, and then that's the variance. And after you get the variance, then you square root it, and that's the standard deviation. Very easy. It's not bad. I'm waiting for like one person to get it, then I'll go through it.
That's great.
You got it? People want wait down, so I feel like you're gonna get it. And I square it.
Yeah, I'm squaring this, right?
Not like so. Neither the So you see how this is like -4, right? So I'm saying you square that. So that's 16. And this one squared, that's 9, etc. Then that's what you have to do. Got it? Right, by n-1.
We just say it's right, because I think it's right, so
It's probably right. It probably is right. I trust you. So you see these numbers here?
That's what
That's what you're gonna square. These numbers that you just found, that's what you squared.
each of them.
Yeah. You're gonna add up all those squares. Right? That's the numerator to the formula.
This is
Mhm.
that's supposed to be a number,
Like a single number. Yeah.
but this part is good. I don't have to do nothing. I'm just trying to get it.
Nah, this part is not good. I'm just trying to find the numerator for here. So the numerator is the square. When you square all these and add them up, that's the numerator. The denominator is just however many numbers there is minus one.
Yeah, that's right.
So 6 minus 1 either. So 5 is right.
Okay,
Just the top part.
that's what I'm moving back. All right, okay.
I feel like you got it.
I'm sure. Yeah.
Let me see. Okay, okay. We're almost there. For the mean, right? Add up all the numbers and divide by how many numbers is that? So 36 divided by 6. That's the limit.
Okay.
Right? Then you go subtract each one of these from them.
Okay. Right, thank you.
I'm here, right?
Got it?
Right.
Let's see. Let's get lower positive though. They're all positive. Because remember, a negative times a negative, positive, right? So all those negatives become positive and the positive stay positive. So you just add those up straight. And then divide it by 5. Gets it off.
Wait, I gotta divide this by 5.
No. Make these positive, and then the sum, when you add up all of these, that number gets divided by 5. All right, I feel like you went for far enough. I feel like you got it. So let's go through this. Right? Yeah. So, yeah, we're gonna go over it. So, Big Blossom Greenhouse was commissioned to develop an extra large rose for the Rose Bowl parade. Y'all ever seen that parade on TV? The joint is fire, you know? I think they have it in like California. It's like a float and it's like mad roses. Like it's just like a whole set of flowers that makes it up, you know? Anyway, a random sample of blossoms from the hybrid A bush yielded the following diameters in inches for the mature peak blossom. So you have 2, 3, 3, 8, 10, 10, right? Then we will have to use the defining formula to find the sample variance and the standard deviation. All right, so here we go, right? First thing we got to do, find the mean, right? So I'm copying straight from the formula sheet. Just straight from the formula sheet. It says that the mean is x bar equal to the sum of x divided by n, right? So once again, that's the sum of x divided by the number of numbers, right? So what am I going to do here? Just add them up. 2 plus 3 plus 3 plus 8 plus 10 plus 10, all divided by 1, 2, 3, 4, 5, 6. That's the mean, right? And then some people told me that it was 36 over 6, so that's just 6, right? After you get the mean now, right? Now I'm looking at the variance. Variance is s squared is equal to the sum of x minus x bar. Let me put that in parentheses. Squared. Go ahead.
It's not 36.
What is it?
No,
It's 34? All right, 34. Y'all sure? Because I really don't know.
It's 1, 8
Yeah.
plus 6 plus 2.
no, but look. 3 plus 3
Hmm.
is 6, plus 8 is already 14, plus
10 and 10. You could
10
have
and 10 is 24.
So,
I mean, no, that's 34.
yeah. So here,
Oh, yeah.
so here's how I so here's how I did it, right? So 2 plus 8 is 10, right? And 10 plus 10 plus 10 is 30. And 3 plus 3 is 6, 36. Right? That's how I did it in my head.
Yeah.
But I'm not gonna hold y'all. That's probably it. I trust you. Yeah, I trust you. So now the next thing that you want to do, we have to make a table, right? So in our table, right, we're gonna write down all our x's. So 2, 3, 3, 8, 10, and 10, right? And then after that, we're going to write down x minus our x bar, all right? So what you're doing is you're taking each x and you're subtracting the mean from it. So 2 minus 6, that's negative 4. 3 minus 6, that's negative 3. 3 minus 6, that's negative 3. 8 minus 6, that's 2. 10 minus 6, that's 4. And then 10 minus 6, that's 4, right? Now you might notice that if you add up all of these numbers, they equal 0, right? So how can we have 0 distance? That doesn't make sense, right? So to get rid of this occurrence, what we do is we square each one of these individual terms, right? So our last column is going to be x minus x bar squared. So I'm squaring all of these terms that I got. So negative 4 squared, that's 16. Negative 3 squared, that's 9. Negative 3 squared, that's 9. 2 squared, you guys get the idea, right? 4 squared, 16. 4 squared, 16, right? These numbers here are what you're going to add up, right? And when you add up these, this is the sum of x minus x bar squared, adding all of those numbers up, right? So what do y'all get when y'all add those up? 70? All right, I trust y'all. And then you divide it by 6. So your variance is 70 divided by 6 minus 1, which is, what's 6 minus 1 again? 5, right? So this is 70 divided by 5. Yeah. No, n minus 1, because we have to copy the formula, right? So what is that, like 14, right? Okay. So that's my variance as squared, right? But they asked us for our standard deviation as well, right? So here's what I want you to remember. Always, right? Your standard deviation is the square root of your variance. Always remember that, right? So your standard deviation is the square root of your variance. Always, right? So this is going to be what? The square root of s squared, which we know is just the square root of 14. And this is where I tap out because I know what the square root of 14 is. But y'all get the idea. Just do it in your calculator. I'm going to do it in mine right now. So I got 3.741657, etc. And that's my answer. Easy, right?
Also, it's big, right?
Huh? Yeah. 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 That's not bad, right? So technically, both of these are your answers, technically. Those two. The 14 and the 3.7, whatever. Yeah. Well, the 14 is your variance, and then the standard deviation is a 3.7, whatever. Mhm. It'll be posted though, don't worry. All right. So let's talk a little bit about this real quick before we jump off, right? Oh, by the way, y'all know I got office hours today if y'all want to stay. Optional, till 4:30. Like I'm literally just gonna sit here and just chill. You know? I got stuff to do though. I'm not like chilling like that, but yeah. I got mad attending stuff and doing all that. All right, so real quick, let's talk about this, right? What do measures of variations tell us, right? So measures of variation give information about the spread of the data. The range tells us the difference between the highest data value and the lowest data value. That's also on your formula sheet, by the way. Talk to me after class real quick, right? Don't leave. It tells us about the spread of the data, but does not tell us if most of the data are or are not closer to the mean, the range, right? The sample standard deviation is based on the difference between each data value and the mean of the data set. The magnitude of each data value enters it into the calculation. The formula tells us to compute the difference between each data value and the mean. Square each difference, add up all the squares, divide by n minus 1, and then take the square roots of the result. So the standard deviation gives an average of data spread around the mean. The larger the standard deviation, the more spread out the data are about around the mean. The smaller standard deviation indicates that the data tend to be closer to the mean. The variance tells us the square of the standard deviation. As such, it is also a measure of the data spread around the mean. All right. So this is what I'm trying to figure out. I'm trying to figure out how far apart all my numbers are in the data set. Appreciate it. All right. That's a trick to this. All right. For a sample, yes. For a population parameter, we don't. All right. So that's actually the next thing I'm going to talk about right now. All right. So in most applications of statistics, we work with a random sample of data rather than the entire population of all possible data values. However, if we have data for the entire population, we can compute the population mean, which is mu, the population variance, which is sigma squared, and the population standard deviation, which is sigma. That's lowercase Greek letter sigma, using some of these following formulas, right? Everything I'm about to show you right now, all on your formula sheet. So you don't got to memorize it. You're going to have it there on test day. Everything is there, right? All you have to pay attention to in your question is what did they give you right now? Did they give you a sample or did they give you the population, everything, right? So here's your population parameters right here. These are your Greek letters, right? So your population mean is mu, which is equal to the sum of x divided by capital N. Capital N because I have the entire population, right? Population variance, which is sigma squared. That's the sum of x minus mu squared divided by capital N. Again, because I have the entire population. And then we have population standard deviation, which is sigma, which is a square root of the sum of x minus mu squared divided by capital N, where N is the number of data values in a population and X represents the individual data values of the population. All right. And then let's talk about this real quick. So we know that the formula for mu is the same as the formula for x bar, the sample mean. And the formulas for sigma squared and sigma are the same as those for s squared and s, sample variance and sample standard deviation, except that the population size, capital N, is used instead of n minus 1. Also, mu is used instead of x bar in the formulas for sigma squared and sigma. In the formulas for the sample standard deviation and the population standard deviation, we use n minus 1 to compute for the sample standard deviation and capital N to compute sigma. Why? The reason is that the capital N represents the population size, whereas lowercase n represents the sample size. Since a random sample usually will not contain extreme data values, large or small, we divide by n minus 1 in the formula for S to make S, the sample standard deviation, a little larger than it would be had it been divided by n. So courses in advanced theoretical statistics show that this procedure will give us the best possible estimate for sample standard deviation. In fact, S is called the unbiased estimate for the standard deviation, right? That could be a question, right? If we have the population of all data values, then extreme data values are, of course, present. So we divide capital N instead of N minus one, right? No, we always divide, right? So what they're trying to say is like if I have a data set, right? I'm really interested in the population parameter, right? But the issue is sometimes it's impossible for me to get the population parameter. Maybe it's too many people, maybe it costs too much money for me to get it, et cetera, et cetera. Tons of reasons why I can't do that, right? So I have a sample, so I'm settling for that. And with the sample, I want to make a inference, an educated guess, a prediction as to what the population parameter could be, right? So one good example of this would be like last year's presidential election, right? So it's impossible for them to go across the entire United States and say to everybody, what do you think? What do you think? What do you think? Right? That costs way too much money. It's impossible to find everybody. You got some people that's like living abroad and they're coming back, etc. Right? So what did they do? They went to like, let's say, densely populated areas, the Bronx, for example, right? And they asked a few people in the Bronx, hey, what do you think? What do you think? And then from that information, they made an inference as to what was going to happen in the election, who they think was going to win, right? And then on election day, you know the actual answer, you know. So that's what this is right here. All right. So just want to make a little comment. The computation formula for the population standard deviation is sigma is equal to the square root of the sum of x squared minus the sum of x squared divided by n divided by n. We've seen that the standard deviation sample or population is a measure of the data spread. So we will use the standard deviation extensively in the later chapters. So we're going to always be using the standard deviation, this idea of what it is. All right. But not to fear, you will have it on your test. All right. Right. That's divide division. Yeah. Which sign?
Even the next to the square, what's the further thing?
Sigma. That's capital sigma. Yeah. So that means you add up all the numbers that are there. All right. Yeah. Yeah. The number. So the sum of x squared, you're gonna divide that by n, then you're gonna divide the whole numerator by n minus one. And then that's how you get that. All right. All right, we got a little bit more to talk about. We'll talk about it tomorrow. All right. I'm gonna stop sharing. Bye bye. I'll see y'all.
Tomorrow, right?
Yeah.